So, Assalamualaikum and very good day to everyone. Today, this is my final topic which to be covered by me. So today's topic is project crashing, which is for currently week 12. So basically today we will cover this topic on project crashing. So first thing first, let me proceed to today's quick chat. Okay, so currently we already here for the third topic under me. So for the next class, Dr. Farida Hanim will cover the rest of the topics starting from next week 13 until week 15, I think. Yeah. Okay. So today will be our third topic, which is project crashing. Then regarding the assessment, as I mentioned previously, my topics will cover for 20% of the assessment marks. So far I already gave you the individual assignment one and also quiz one for previous 2 weeks. So that one already contribute for 5 and another 10, 15. So the rest 5 marks will be covered for today's topic. So hopefully you can properly pay attention and understand well regarding to this topic. Alright. So let me proceed to our topics outlines. Alright. For today, basically, as usual, we will have several subtopics, which including the first one is the overview or introduction of project crashing, which is for this subtopic, I will explain more on the fundamental and also conceptual parts of this topic. Then we will move to the second subtopic, which is relationship between time and cost, because these two components are very significant or very crucial for our today's topic, which is project crashing. And then I will proceed the rest of the subtopics which cover reasons of project crashing, ways, and also related assumption for us to be considered in regards to project crashing. And then starting for this sixth subtopic, we will cover on the calculation parts for project crashing. So I will show you the step-by-step calculation for you to easier and to understand the step to prepare the project crashing calculation in a what we call clear and simple way. And the last part, we will, as usual, we will cover on the overview of sample questions. All right. Okay, for the first starting for this topic, basically, project crashing is an activity to shorten the project duration, specifically by reducing the time of one or more activities and also to increase the resources. That's the main fundamental parts of project crashing. So in other words, other names to call this project crashing, it is also called as project time. It should be cost here. Time cost trade-off. So this one, let me have some correction. This one is cost. Sorry for the minor mistake. Okay. So it is also called as time cost trade-off because these two components are very important for this purpose of project crashing. Then besides that, it's also called as project compression because crashing is similar to the how we compress the project in order to meet the specific or desired target in terms of times or also in terms of the resources usage. The other two names are project crashing, also known as project expediting and also shortening. Obviously, it is basically a shortening process of the actual project duration to the new project duration or project time in order for the contractor to meet the deadline, especially during the emergency requirements. All right. So before we proceed in detail for our today's topic, let me show you the today's. I think here we have short video for the for which related to our today's topic. It is a video on the fast track construction project, which is in China. So let's us watch the video first before we proceed with our today's class. Can you see and hear the video? All right. All right, that's all for the fast track construction project video. Can you see the video well? Is it clear for you? Any of you?
Doktor dia macam ada delay sikit, maybe connection kot.
Alright, so ada buffer juga lah.
Sikit, tapi overall boleh je tengok.
Alright. Tu pun saya pun rasa memang akan ada buffer. Tapi boleh tengoklah dari awal sampai habis
Yes.
Okay,
Yes.
thank you. Alright, thank you. Okay, that's all for the video sharing. So basically, this project is actually an example of a fast track project, which we can see physically that the project has a very compressed works in terms of their time and also the resources usage, because as we can see, the project has utilized more machinery, especially the tower crane, and also the project has utilized the construction of using IBS and also precast concrete in order to what we call to reduce the project duration in meeting their target deadline. Okay, that's the overall overall overview of the fast track project just now. Okay, so now we will proceed to the still on the introduction part. So basically this slide is revision or review of the previous lecture. Basically, I have showed this slide to you on our first meeting, I think, during week 10, because this is basically the types of cost, which is quite important, and all of you need to always remember the types of costs in order for you to prepare the project cash flow, or also to do the project crashing, because these two components are related to the cost. So by hook or by crook, you need to properly differentiate the cost and identify the cost. So as previously mentioned, contract or project value is equal to total cost and profit. So basically, I have mentioned this formula quite several times, and hopefully all of you already remember this basic formula. And also, just as a revision, I would like to highlight again, total cost is equal to direct cost and indirect cost. So later on, we will use and apply this basic formula for our calculations. All right. Okay. So far, is it clear, right?
Clear, Doctor.
Alright, okay, that's all for the introduction part of project crashing. Then we will move to the relationship of time and cost for project crashing topic. So basically, the second subtopic is also a fundamental or conceptual part of our today's topic. So, what actually the relationship between these two components? So, as we can see here, we have a simple graph for the cost or time versus cost, which show the relationship between these two components. So here we have three different, as I mentioned before, we have three different main costs, which we need to always remember. So for the plot for indirect costs, so basically it will have the linear relationship between these two components, which will form this kind of straight line. However, for the direct cost, which contributes to 90% of the total project cost, will form this parabolic shape of inverted parabolic shape of the graph. So similarly to the total cost, because it obviously will follow the shape of direct cost, because direct cost contribute to 90% of the total cost. Meanwhile, for the indirect cost is only 10%. So for sure, the shape will be the same with the direct cost here. Because direct cost is 90%. I already mentioned this quite several times. All right. So the final shape supposedly in this kind of shape, which is inverted parabolic. So the meanwhile for the middle line, this one showing the optimum cost or the minimum cost for any project to be conducted. So what we can summarize here is that this one showing the time, basically year or day or month maybe, and this one cost. So as we move towards, for example, this one for maybe for 100 days, this one for maybe this one for 2 years, and the middle will be 1 year. So as we can see here, basically if we conduct the project within 2 years, based on the conceptual part, the cost will be here, meaning that the planned cost. So if we try to compress the cost, so maybe the cost will, if we want to try to compress the duration, maybe 1.5 years, the cost maybe will be here. Yeah. So, So there will be some reduction or decrease of the cost. However, at optimum cost, if we already or the planner already prepare the cost at an optimum cost, so supposedly if we have more project crashing or we still have more project shortening from 1 year to maybe half year only, so later on the cost may increase as the what we call as the time decrease, the cost may increase. So later on I will show the details of this relationship. All right. Okay, this is the table to summarize the previous conceptual graph. So basically, if we have increased the time, so for sure the direct cost will increase and also indirect cost, because basically indirect cost will be counted for on daily basis. So if these two items increases, so for sure the total cost will be also increased. All right. Meanwhile, if we try to compress, this is for the project compression, compress or crash the project. So meaning that we want to decrease the time. So at certain point, the cost may also increase. However, indirect cost is vice versa, because as we shorten the duration, the daily indirect cost will be reduced or decreased. But the total cost still maintain increase, because it basically follow the direct cost. Because direct cost is the significant contributor to the whole cost or overall cost. All right. So the reason is that for the direct cost to increase, because if we as the time increase, there will be efficient use of resources, either in terms of machinery, manpower, and also materials. However, there will be also increases of resources as the time decrease here. If we want to compress the project or crash the project, for sure, we will need more resources, as previously shown in the fast track construction project. Uh, if you can notice that they use more or lots of tower cranes as their required machineries for the project, because they maybe want to speed up the construction or project progress, so that they require or they need extra or more machineries, manpower maybe, and also the materials. All right. Meanwhile, for the indirect cost, it is proportional with the time. As the time increase, for sure the indirect cost will decrease. So for indirect cost, any of you still remember what actually indirect cost? The examples. Any of you can recall regarding the indirect cost? Any volunteer?
Staff salary.
All right.
Office rental.
Okay. Okay. So basically, staff salary and also office rental fall under the category of management cost. So for sure, it will proportional to the time, because as the time increase, it will also increase, and vice versa is the when the what we call when the time decrease, so the cost will also decrease, because we have only short duration to allocate the money for indirect costs, especially for the salary and also any management costs. All right. So as I mentioned before, for the total cost, it practically may increase as the direct cost. So basically, it will tally with the direct cost, because direct cost contribute to the most of the cost. Alright. That's all for the relationship of time and cost. So now we will proceed to the reasons of project crashing, which is why we need to crash or compress or also to shorten the project duration. Alright. Okay. Here, herewith, there are several main reason of project crashing. First of all, any project crashing will be conducted if there is a request by the client in order to complete the project ahead of the actual schedule time, meaning that the client requests to the contractor that the project need to be completed maybe in a shorter duration than the actual plan duration. For example, if if the project has the total duration of 2 years, maybe if possible the client requests the contractor to construct the project within 1.5 years. So basically, for a simple example, we take the housing project. Basically, the housing development, they will have what we call several stages of construction, right? So for example, they have stage 1 and also stage 2 or the fasa, which is the phase 1, phase 2. So basically, if the client requests the contractor to compress the project in order for them to have a good what we call cash flow and also to roll the money in order to provide the accommodation or the facilities to the customer or purchaser. Alright, so basically this is advantage because the client themselves request the contractor. So it will be bonus or advantages to the contractor because it is come from the client parts, not the contractor parts. However, for the second one is regarding the penalties. Penalties is basically related to the delay. Alright. So basically delay problem is quite common in any construction project. So delay of earlier activities may force the contractor to reduce the remaining time of the project in order for them to meet the actual schedule. So in any project, if the contractor notice that they already behind the schedule, meaning that they have some delays regarding the early activities, so there is a need for them to crash the project for the upcoming activities so that the delay activities will not affect the rest of the activities. Alright. So that's also can be the reason for project crashing by the contractor. Okay, the next reason is that freeing resources. So basically, this kind of situation is when the contractor have the new project opportunity or upcoming project, which is concurrently to their current project. So there is a need for them to move out the resources to the new sites. Resources can be in terms of basically plant and machineries, all right, and also the manpower. Okay, so basically these are the main resources for any project. So for them to freeing the resources, so for sure they need to crash the activity or the duration of the existing or the ongoing project, so that easier for them to move out their resources to the new site. Alright. The other reason or the main reason also regarding the seasonal consideration. Okay, seasonal consideration basically related to the adverse weather conditions such as heavy raining and also flooding, which is currently is the situation in our places, mostly in several states in Malaysia, because we have currently have heavy raining and also flooding issue. So basically, this kind of weather condition will force or will require the contractor to have project crashing activities in order for them to try to compress and also to shorten the project duration in order to avoid the adverse weather condition. Meaning that at the earlier stage, they already have the forecast or the prediction of the upcoming weather condition. So they need to plan for the project crashing based on their own requirements. All right. Okay, the last reason is that regarding the impacts. So basically, it's related to the error in purchasing excessive materials. So sometimes there will be some issues regarding the mistakes in purchasing the materials in bulk quantity, and supposedly at that time they still not there's still no need for the materials to be used. However, there is excessive material purchasing, so that contractor need to also crash or shorten the project duration in order for them to avoid any wastage regarding the materials, because they already purchased the materials. So for sure, it if there is any wastage, it will affect their cash flow. So they want to avoid the negative cash flows. Okay, that's all the main reasons for the project crashing requirement. Okay, so far, do all of you clear? Do you have any questions so far before we move or proceed to our next subtopics? Is it clear?
Yes, teacher.
All right, thank you. So hopefully so far everyone can get the main idea of the project crashing and why we need to conduct the project crashing or project compression. All right. The next one will be the ways to shorten the project time. So basically, there are two main items for us to conduct the project shortening. Basically, the first one is resequencing activities, meaning that we need to rearrange the activities, the main activities, especially the one which is quite significant, contribute to the total project duration. And also, we can also accelerating the activities. Okay. For the resequencing activities, it is required because constraint can eliminate coordination problem. So by eliminating the coordination problem, we will can have a better project or shorten project duration. The other is that we can also resequence activities because some of the activities may unnecessarily delay the project completion. So the planner or the contractor themselves need to double check on the activities sequence. So they may find any potential activities that can be rearranged, or maybe some of them can be removed if it's not affect the project progress or project completion. All right. The other one is that any activities which is not really significant, should be avoided unless essential. So the activities can be resequenced or rearranged if it is very required at that time, or for the contractor to meet the target for the project completion deadline. So that's the main ways for the contractor to shorten the project duration. The other one, for accelerating the activities, as I mentioned earlier, is that schedule cost is usually optimum or minimum. So that previously or at the early stage, the planner or the estimator has prepared the cost at optimum or minimum cost. So if we refer back to the what we call to the graph just now, we have this inverted parabolic shape, right, for the direct cost and total cost. Sorry for the bad drawing. So the middle one will be the optimum cost. So let me show you again the, okay, this one. I mean this one. So the planner and also the estimator has estimate the cost to be at the optimum level. So it should be here. So practically for the academician purpose or for the for our class, so we must bear in mind that the cost is already at optimal level. So if the contractor try to shorten the duration, so obviously the cost will be increased. As the time decrease, the cost will be increased. All right. Okay. So that's why accelerating activities may increase the cost. Okay. The next point is that it's really feasible to completely crash the activities. Okay, so here is that meaning that it is impossible for the contractor or for us to completely crash the activities. Meaning that if they have 1 year duration, maybe it can be up to maximum half year duration for an activity to be completed. So for any activities, it should be the maximum crash duration that can be used or utilized by the contractor, because it can be completely crashed. Okay. Okay, the next one is that shorten the project at the least cost. Oh, this one will be, I will explain more details later on. Okay. Herewith we have several ways also how to crash the activities, meaning that the single activities of the project. All right. So basically, if we want to crash the activities, any specific activities that possible to be crashed in order for us to meet the desired deadline for the project completion. So we can focus on three main resources of the project, which is the manpower. The first one, manpower. So we have second one, machineries, and also materials. These three resources also have been mentioned several times. So hopefully all of you so far can already understand and remember regarding these resources. So in order for us to crash the activities, we may require extra manpower for each activity, and we also may need to have multiple working shift. Okay, if we relate back to the previous what you call previous video, fast track construction project, they may have this kind of ways to crash the activities, because for sure they will have multiple working shift, and also they also will have extended or extra working hours. They may construct the project starting from day until the night, so that they have extra working hours in order to achieve their desired deadline for the project completion. And in terms of machinery, they may require larger plant and also high numbers or quantities of machinery or plants at the construction site. As we've seen previously that the fast track project require more tower crane, so that maybe by utilize more tower crane or any related machineries, they may increase their what we call the output of the project. So that's the main reason they will utilize additional equipment or any machineries related for the specific project. Alright, in terms of materials, we will have more costly materials, but it more quickly to be installed or to be constructed. For example, we have the IBS system. For sure, IBS is known for its quick construction method. However, it is quite costly. So that's the what we call the explanation regarding the materials. All right. Okay. Continue to the ways to shorten the project time. Here I have a simple example regarding the time versus cost. Okay. So based on this table, we have the information regarding the estimated daily production, which is by meter square. For the activity to install the metal siding. So herewith, we have several crew size based on each what we call the meter square or square area to be completed based on each crew size. So for example, in order for us to calculate the duration required for installing the metal siding, so for sure we need to know the detailed cost for each labor and also for the material or any equipment itself. So by having all these detailed costs, we can have we can calculate the duration, because for example, the total area is 7,700 meters square. So if we divide it with the first option, in that if we want to use the crew size A crew size, so we need to know the expected or estimated daily production. So we need 65 days for the task or the activity to be completed. So it's just a simple calculation. Okay. So here is the summary or the summary table for detailed calculation based on the previous crew size. So herewith, it's already calculated that the duration and also the cost for each crew size. This left hand side is actually the approximate values, and this one is already the run off values. All right. So basically here we can see that we need to know the cost for each crew size or the manpower required for each option. For example, crew size A, which is option A. Previously, it's already mentioned for the A, we have only one scaffolding site, two laborers, one carpenter, and also one carpenter foreman. So this is the breakup of the calculation for the cost, required cost. So the total we have 364 per day, meaning that the daily cost required. So as calculated previously, the duration to complete the task is 65 days. So herewith, we obtain the total direct cost for this specific simple activities, which is installation of metal siding. Okay. So basically what I want to show here is that because we have several option or various option to be utilized. We have the crew size of A, B, C, and D. What we have here is that if you utilize crew size A, then we will have this cost, right? 23,660 ringgit. If you utilize the second one, okay, we can see that the cost is decreased because they have the different groups or the details for the team B or crew size B. One scaffolding, two, instead of one, they have two carpenters and also one carpenter foreman. So as we can see here that if you utilize the crew size B, the cost will decrease. However, if we decided to use C and D, the cost will again will again increase. So the shape is that the cost from here it will increase. Then from the first one A will have 23,000 something, and it will decrease until 22,000. Then again it will decrease here. So basically the planner or estimator need to properly select each what we call suitable or optimum crew size, because this one related to the manpower, in order for them to have optimum cost and also minimum cost of the project. Okay, so this basically the summary of the previous one. All right. Okay. As we can see here that if we conduct the project, if we want to conduct the project to be completed within 65 days, this is the cost. And if we choose to 51, all right. Oh, sorry. 51, then the cost will be here. And if we decided to reduce more the time, the cost for sure will increase again. So based on these four types of cost, or based on the calculation, we can see that 51 days is the optimum duration for the activities to be constructed or completed with the optimum cost. All right, that's the main basic or the main idea of this example of the time and cost calculation for the daily production, what we call estimated daily production. Okay. So far for this simple calculation, all of you can understand, right? Is it clear? Before I proceed to the next one.
Okay, doctor.
All right. So hopefully everyone so far can understand. All right. Then I will proceed to the assumptions of project crashing. So we currently moving or proceed towards the more on the calculation part. But before that, let me share the what we call important assumptions of project crashing. Okay, basically we have here is that the first one, the cost and time relationship, as previous graph I shown previously. All right, so the main important thing is that here the line colored plot, this one, refers to the close approximation of the cost of or the value that have been calculated previously, similar to this one. This is actually the approximate cost or close approximation of the calculated cost, mean that this is the actual one. However, for the purpose of our today's topic and also for the academic purpose, we will consider the cost slope. Basically, cost slope is the linear relationship between the cost and also time. So it is a straight line here formed. So it is known as cost slope. Alright, so cost slope is the linear relationship of activity duration and also direct cost. So later on our later example and also calculation, we will focus on this item cost slope. So the other item which is important for this graph, we have 4 main items, which is CC, this one, NC, normal cost, CC, crash cost, this one crash cost, normal cost. We have CD, crash duration, and also we have normal duration. So here is that normal duration, as previously mentioned, is the actual or the yeah, that's right, the actual time for the project to be completed, actual duration. Okay, for example, we have here 2 years. So crash duration may be less than this one because we have crashed the duration, so it can be less than 2 years. Less than 2 years, maybe around 1 to 1.5 years, based on our later what we call calculation, and also based on the requirements for the specific project. So you need to always remember these 4 components of this time and cost relationship, and also this component cost slope. Alright. So the next assumption is that we have the equation to calculate the cost slope. So this is also the one of the important or basic formula, because later on we will have to use this calculation, this formula for our calculation. You need to remember that in order for you to calculate the cost slope, you need to do the deduction of crash cost with the normal cost and divided with normal duration minus the crash duration. So basically it's just a simple formula. However, you need to properly remember this. Okay. The next one is assumption of that some activities can be crashed or shortened while some of them cannot. Okay. So you need to always remember that not all activities can be crashed, because you need to what we call determine and identify which activities is the most suitable to be crashed, and you need to what we call observe the duration, the total duration required for the project, and need to identify whether is it possible for you to select any activities to be crashed. Okay, later on we will relate this kind of assumption to the detailed calculations. Alright. So basically, before we move to the project crashing calculation, I will show you the simple calculation regarding the cost slope. Alright. So here we have a simple activities of activity A, which have normal duration of 10 days, and it given that it stated that the activity A can be shortened to minimum limit of 6 days only. Okay. So meaning that 6 days refers to the, anyone can answer this? 6 days is referred to what?
Crash
Any of you have?
duration.
Yeah, yeah, that's right. Crash duration. So basically 6 days is the CD, crash duration. All right. So proceed with this. It also mentioned or stated that the cost of completing the activity is 6,000 within 10 days of normal duration. Okay. But if it's completed, to be completed within 4 days, the cost will be 10,000, meaning that for the what we call the crash cost. All right. Oh, this one normal cost and also this one for direct crash cost. Okay, so basically based on this information, you just need to transform them into this what we call cost slope formula. So you just need to do the straightforward calculation by minus the crash cost with the normal cost, and also sorry, crash okay. Then divided with the normal duration ND and also CD. So you will simply have the cost loop for activity A. Okay, so basically, what is the meaning of this value? So this 667 per day is referring to that it costs about 667 per day to crash duration A. Meaning that if you have activity A, so later on we can relate to the detailed calculation. The cost to the cost per day, which is the daily cost for activity A, if we have some project crashing, it costs about 600 additional extra cost of 667. Okay, so we need to bear in mind because cost loop is very important for the project crashing part. All right. So I think currently we already. Okay. You want to proceed or you need maybe 5-minute breaks before we proceed with the project crashing calculations. So can I just proceed or we need break first? Because later on we will have the calculation.
I think we can proceed.
Okay. Can proceed, right? All right. Okay. For the next subtopic is that steps of project crashing. So basically, we currently already reach the calculation parts for the project crashing. But before that, I will show you several steps to be followed in order for us to prepare the project crashing or also project compression or shortening. Okay. So basically, in order for us to have or to do some project crashing, in order for us to shorten the what we call the duration of any specific activities, what we need to do is that the first one, we need to prepare the network diagram. It can be either AOA or AOA or AON. Alright, sorry. AON. So basically these two networks, the details of network have been covered at the early of our previous lecture, which is by Mr. Rahim, right? Okay, so hopefully all of you already familiar and already uh, able to prepare the network diagram, because network diagram is the main or the core component of project planning and scheduling. All right. So once you have the network diagram, you need to determine the normal duration and also the critical path. All right. Critical path of the project. so that you need to identify which activities is critical that contributes to the critical path. Okay, so any of you have can explain what is actually a critical path? Can you still recall or remember regarding critical path for the network diagram? Any of you?
Critical path can have a zero total float.
Okay. Sorry. Okay. Then, so you just said just now critical path have?
Zero total float. Zero duration.
Okay. Alright.
Okay.
Alright. So basically critical path refers to the longest duration of the activities. So later on we will look at on this detailed network and also the critical path. Alright. Then wait. We also the next step is that once you have the detailed preparation of the network diagram with the normal duration and also critical path identification, then we need to calculate the cost loop. Okay, as I mentioned just now or shown just now, the formula for the cost loop, we need to use the formula to calculate the cost loop, which is using the equation or the formula. Alright. So basically the calculation of cost loop is quite straightforward and simple. However, you need to properly identify the four components such as normal duration, crash duration, normal cost and also crash cost. That four main components need to be available for you to calculate the cost slope. Alright. Then the next step is that we can start to crash the activity. In order for you to crash the activity, the main step is that how you select the activity, which activity to be selected, so that for you are able to crash the duration of the project in a proper way or in a correct way. So you need to remember that you need to select a critical activity with the least cost loop. So basically you can start the project crashing or to shorten the project duration. First, you need to select the critical activity or critical path, any activity on the critical path with the least cost loop, because least cost loop will affect the total cost less significant as compared to the higher cost of cost loop. Alright. Then throughout the process, you need to recheck the activities because for example, you have network diagram, simple network diagram. Sorry, this one is AOE basically. Okay, sorry, maybe at the earlier, before you crash the project, the critical path only in the middle, but later on once you do some project crashing, you will notice that the other path or the other relationship also will become critical. So that's why you need to recheck the activity in order for you to look for the additional formation of second, third or so on critical paths. Maksudnya so that you need to identify any succeeding or other critical path. Alright. Let me connect to the. Okay. Once you have done all the crashing part, then you need to recalculate the new direct cost. Okay, so any project which is in its normal condition, meaning that before crashing will have the normal cost. Then after you have done shortening of the project duration, so for sure you will have the new cost, new direct cost. Okay, so that this one that require you to recalculate back your new cost. Then beside the direct cost, which is DC, we also need to consider and recalculate or includes also the indirect cost. Basically, this one is based on the given situation. Some of the example of question just require you to calculate the direct cost. However, some of the sample questions or situation also include the indirect cost. So you need to properly identify which one is the direct cost and which one allocation for indirect cost. Because later on, if you have been given assumption for indirect cost, you need to do some deduction. Because as I explained previously, if we shorten the duration, meaning that if we recall back the previous table, if the time decrease, shorten, if the time shorten, this one for time, so most of the time direct cost will increase. However, it vice versa for indirect cost, because indirect cost is proportional to the time. If we require less time to construct the project, so for sure indirect cost will also be low and need to be deducted from the total cost. All right. Okay. So basically, this is the first example. Basically, it is a simple example before we go more detail later on. Okay. The one that I put number here 1, 2, and 3 is basically refer back to this step 1, 2, 3 until the sixth step. Basically, we have 6 main step. All right. The first one. Just now we need to prepare the network diagram, so it's already given here, so that the first step is settled. Also the normal cost is already given here. For the next step, the cost loop is also given together with the network diagram. And the third step is that you need to identify the critical activity and also in that critical path. Okay. So based on these activities, based on this network, we have AOA diagram, activity on arrow. Okay. We can see that the critical activities is task 1. So the critical path will be from this node 10 to 40 nodes, and the total duration is that 10 days. Okay. So basically this is the condition of the networks before we do the project crashing, which is this is the normal condition. Okay. Sorry. Let me check. I think some of you want to admit. All right. Okay, let me proceed. Can you see the slide, right? I re-share the screen. Can you? Can you see the slide? Because just now I need
Yes,
to
betul.
admit. All right. Okay, then I will proceed for the example 1. So just as I mentioned just now, this is the condition of the network before the project or the duration has been crashed. Okay, the next one is the first, meaning that the first situation after we do the crashing of task A. Okay, so basically we have crashing duration of 1 day. So basically we can do the crashing because task A have what we call the crash duration for 10 days. So we can minus 1 days for the new duration, which is it will become 9 days. So we need to double check which is alright. So the total what we call the total project duration is now the new one will be 9 days. Alright. So the rest of activity B and C we also need to double check because task B already have the 9 days duration, so that since the total duration is 9 days, task B is also now be critical. Is now critical also. So that's why this is the existing or the normal condition. Because the maximum is 10, now it become 9 days for the total project duration. Then the task B will also now critical. Okay. Task C still maintain the same conditions. Okay, what we have here is that for the number 5, we need to calculate the new cost. Alright. The new cost is that it's given that the normal cost or the total cost supposed to be 5,000, right? Okay, if we have done the crash or shortening the activities for task A, which is for 1 day, we need to check here is that cost loop. Cost loop for task A, 100 ringgit per day. So we have crash for 1 day, from 10 become 9 days. So we need to add extra 100 here for the new total cost. So now the total cost is 5,100 because we already crashed one activity, which is A, contribute for cost loop of 100 ringgit per day. Alright. Okay. So the next one is basically further shortening of the project duration, which is the condition of crashing task A and B for 2 days. Alright. So from firstly for the task A, we have previously we have crashed from 10 to 9. Now we have another 1 day to be crashed. So the new project duration is 8 days. Alright. Similarly for task B, we also minus 1 day from 3 and now it's become 2. And the duration for task B is also 8. Alright. For duration task B is similar to the total duration. And now task C also become critical. Sorry. Alright. I forgot to include here. Now critical for task C also because the normal or the given duration is 8 days, which is the same with the other task duration. So supposedly now, for if we crash the task A and task B for 2 days, all tasks or all activities has become critical. And how about the new total cost? So we need to recheck again which activity or which task has been crashed, so that we need to do new calculations. Alright. Okay, the first one is that we have crashed 100. Okay, here. Previously, this one is cumulative. Cumulative from the previous one, this one, 100. So for the current one, we have another 100 because we have crashed activity A. We have shortened the duration. So the next one, this one 75 ringgit because we crashed the activity B, and then we need to total up with the normal cost, which is this one, the given at the first place. What is the normal cost? It is 5,000. So we just need to calculate the new one. So this will be the new total cost. In meaning that for this scenario, for this crashing task of task A and B for 2 days. Alright. Okay. We proceed again with more crashing of all activities. Okay. We will crash the activities or task A, B, C, A, B, and C, meaning that for all tasks which contribute for 3 days of crashing duration. Okay, so from 8 days we crash one more day and it becomes 7. So obviously the total project duration will be 7 days. And for the task B, we also minus one more day, so it also becomes 7. So the next one, task C, we remove one more days or shorten one more day, so it also becomes 7 days. So basically all of these 3 activities become critical. It's now critical. Supposedly this task C also red line. Okay. So the new project duration is 7 days. So similarly, we just need to repeat the same calculation for us to have the new calculation for what we call for the new total cost. So previously we have this cost if we crash 2 activities, and if we crash more activities including activity C, the new total cost has increased from 5275 to 5,500. Okay. So basically this is the summary of what we have done previously. Okay, as we can see here is that we have the time as usual. The bottom one is the time or the duration, this one, and versus the cost. So for the normal or the existing case, for the normal condition, we have 10 days to complete the project with the cost of 5,000, this one. So basically, as I mentioned before, this is the optimum or the minimum cost proposed for the project, or minimum. Alright, minimum cost. So the first scenario, if we crash activity A, so the total duration will be decreased for, or will be shortened to 9 days. However, the cost increased for 1 more 100 because the cost slope for activity is is 100. Then if we further crash the duration or the activities, the cost is getting bigger and it increase as the time decrease. So this is basically want to relate back to the conceptual part that I have shown you previously. So so far, can you understand this crashing calculation or how to crash the activities? Starting for this example one. Do you have any question on how to do the crashing or any related question? Is it clear for all of you? before we proceed more on the calculation part?
Yes.
Okay. Okay, thank you. All right. So basically, this is, we will now proceed to the example 2. So, most of the, most of the question of or the sample example will give you information in this kind of form, which is in table form, so that by your own you need to prepare the first step, which is prepare the network diagram. So based on this table, we have the information on activity. For sure, we need to have the detailed activity, durations, cost. So the duration will be divided by 2 normal and crash course, which is the same for the cost. We have the CN, NC normal cost, and also CC crash course. So other information is that critical path activity, it is given that the critical activities is are this B, C, D, E. So later on, B, C, D, E path will be the critical path. And for this example, for the second example, we have the item or step number 6, which is the assumption of indirect cost, which is the same as I mentioned previously. We need to consider any calculation of indirect cost if it is given for you. Basically, you need to properly identify the assumption regarding the indirect cost. Okay, so basically for this example, it is given that the indirect cost contribute for RM 50 ringgit per day. Okay, so you will use this assumption later on in the calculation. Alright, so for the first step, you need to, before you prepare the is it okay for you? It is both okay for you either to prepare, you want to prepare the network first, or you want to calculate the normal cost at the first place prior to the preparation of network. So basically here what I have is that I have calculate the direct cost and also cost load for this project, because it's already given here in terms of its ND, normal duration, crest duration, and so on. So for sure we will have this cost load calculation. So in order for you to have this value, you just to use the previous formula of cost load, which you need to use all these 4 items. 1, 2, 3, and 4. You need to do some deduction, and also you need to divide the values. Alright, so straightforward, you will obtain this cost load value. Then you also need to know the normal cost for the project, which is the actual total cost for the project. So that here you just to do some total up or summation of this normal cost, then you will have the total cost. So for this example, you have 48,300 for the total cost, and the project duration, because it's already mentioned that critical path B, C, D, and E. So for sure the total duration will be the longest duration. Then you need to sum up this value, and it's contribute to 140 days. Okay. Now we transform this table form to the network diagram. Again, this is also a AOA diagram, network diagram. So what you have here is that you need to have this one note to what we call to identify the path of these activities 1, 2, 3, 4, 5, and basically the details activity is on the arrow. Basically the activity A, refer back to the table. We have normal duration of 120, and then for these two is actually similar to previous example. 20 is basically, sorry, 20 is basically, so let me erase, what we call the crash duration. You just need to, what we call okay, you need to do deduction from this 120 and 100, so you obtain the crash duration, meaning that this duration is the maximum allowable days to be crashed. So at the maximum situation or scenario, you can only crash this activity for 20 days only, and 100 is actually the cost per day, meaning that if you crash one day, so that the cost per day for this activity A, once you shorten the duration, it costs about 100 ringgit per day. So basically, this is the details of the value here. Similarly to the rest of the activities B, C, D, E, and also F. Okay, so you need to write down all these required details or the required value. Then, but by preparing this what we call network, you need to highlight also the critical path. As mentioned previously, B, C, D, and E is the activities for critical path. So that's why this the red arrow which represent the critical path. So the total duration will be 140 days. So meaning that this diagram or network diagram refers to the normal condition before the project crashing. And before that, you need to also calculate the total cost, because just now we actually have this one direct cost. Direct cost, DC. The total here is actually direct cost only. Then you need to calculate with the summation with the indirect cost. So based on the given information, based on the assumption, the direct cost is 50 ringgit per day. So you have here is that 140 for the total duration. You just times the daily what we call daily cost with the total duration. So simply you can obtain the indirect cost. So you just total up with the direct cost, then this is the amount for total cost for this specific project. Okay, this is the normal condition. Then we'll proceed to the we will start to shorten the activities by crashing the activity D. So the question here is that why we start crashing activity D? Any of you can try to answer this? Any of you? So far, is it okay? Any volunteer? We have Mohammed. We also have many of you. Ruzaini, Zuraina. Any of you? Can you hear me? All of you are still here?
Itu cost loop dia paling sikit.
Okay. Siapa ni?
Nuraini.
Ruzaini?
Nuraini. Aini.
Nuraini. Alright, thank you. Okay, that's the correct answer, because this one have the minimum cost slope. And also we have another reason. The main reason is that why we choose D instead of A. Do you notice that? Because it is already stated that this activities is on critical path. So that's the reason why we choose D. First of all, because it is on the critical path and also it has the least cost loop. Alright. So for example here we have crash the activity D for 10 days. So the new duration for activity D is become 20 and it will affect the rest of the duration. So here we have 80. The total, the new total duration is that 130 days. Instead of 140, it has been shortened to 130. So that's the part of on the network diagram. Then we need to recalculate all the new total cost. So what we have here is that we need to recalculate that this one is the normal, meaning that the normal one, normal total cost previously, NTC this one. Okay, we need to add the additional cost due to the crashing activities. So for activity D, the daily cost is 60 ringgit. So need to times with 10 days because we already crashed for 10 days. Then we have this value. However, you need to bear in mind that you already have shortened the duration, so you need to consider the indirect cost. So that's why here we have the deduction, because now the what we call the total duration 140 has become 130. Alright. So now the duration already decreased for 10 days. So for sure, as I mentioned previously, as the time decrease, the IC also increase because it is proportional time and also indirect cost. That's why we have need to do some deduction here. So the new total cost will be 55,400. Alright. That's the scenario when we crash activity D. Now, we will do more crashing because we want to we want to crash, we want to have the we want to do the crash until its maximum limit. Alright. Okay, then just now we have crash activity D, meaning that D is no longer can be crashed because it's already zero. We already remove or shorten all the allowable crash duration. Then we proceed again with the activity E. Okay, again, why we need E is that as we compare here, at the normal situation, the critical path is that B, C, D, and E, right? Okay, so that's why we firstly chose the D because it's on the critical path and also it has the least cost slope. Then E has been chosen after D because it also have a smaller cost slope as compared to B and C. That's why the next we choose is that E. Alright, similarly, we have crash 10 days from E. So now the duration become 120 days. Okay, so this middle arrow part is quite clear. How about activity A? Alright, Activity A previously it's not on the critical path. However, as I think the fourth step, I think we need to recheck other activities. Now activity A also become critical because its duration is 120 days, which is the same with the total project duration. So for sure A also become critical. Similarly for F, the total is 60. Here we have 40 and 20. So the what we call the activity or the task also become critical. So now we have all the tasks, all the network or relationship become the critical with the total duration of 120 days. And the same, we need to repeat the same step. We need to recalculate the new total cost based on the previous one. This one, we have do we have do another crashing activity E. So it costs about 120 times by 10 days here, because we have we have shortened the duration for 10 days. So that's why 120 times by 10 days. Then similarly, once we obtain the new cost, we need to again deduct for the allocation of indirect cost, because we have 10 more days has been shortened, so that for sure IC or indirect cost also need to be deducted for 10 days also. So this one is the new total cost for this project once we have crash activity D and also activity E. Alright, so far this is the calculation, the crash we have done. Alright, we can still check whether we can still further crash the activities. Alright, so actually we can, because we still have another activities on this critical path that can be considered. Okay, for this example, we proceed with the crashing of activities. Just now we have done D and E. Now we proceed to A and B. Okay, B was selected because what we call B have a lower cost slope than C, and also the same with A. A only have 100 cost slope as compared to C. That's why we firstly choose A and B instead of C for this scenario. Alright. So what we have here is that B existingly it have 5 days for the maximum duration to be crashed. So here we have shortened use or utilize all of the maximum days, so it becomes 0. Then we need to have the new duration, which is from 20 reduced by 5, it becomes 15. Then we need to recalculate all the durations. Similarly for A, we have reduced 5 days because now the critical path become 115 due to the reduction here, shorten here. So similarly, you just need to tally all these crash duration in terms of its final, what we call final project duration with the calculation for you to obtain the latest or the current total cost based on what you have crashed, based on activities have you crashed, have you shortened. So similarly here you have to include the cost slope for this one for activity A, right? Okay, 100 times by 5 because this one already reduced by 5, and this one 200 by 5 for activity B, Similarly, you need to deduct for the indirect cost, and straightforward, simply you will obtain the new total cost. So basically the step is a repetition until you obtain the what we call the optimum or the allowable or also the maximum limit for the crash duration, meaning that the shortest duration for you to construct the project. However, you need to look at back the cost, because any reduction of time will affect the total cost. So we need to balance the times and also cost for any project. Okay, so basically this is the further calculation of this example, because we have more crashing, 5 more days, and it will affect on activity again A, C, because previously we still don't do any shorten of project for shorten of time for activity C and F. Then here we have shortened all activities. Okay, for the A, C and F, we try to shorten for 5 more days, and then it will become 110. Okay, total the new total project duration. Okay, basically this is just the same or similar step. You just need to do the addition and also deduction based on what activity have you crashed, and also consider consider the indirect cost, and consider how many days have you crashed for the indirect cost calculation. Okay. Okay, then this is the new one. So basically, we check recheck again D, because just now previously we have start with activity D. D already 0. This one already 0. E already 0. Similarly to B. Now C we still have 5 days, and also A and F we still have the days allowable to be crashed. Alright. So if we want to proceed again, if we want to crash all the allowable days here, we can do another crash on the activity C, because at the first place this is the critical path. So A and F also need to have some what we call some reduction lah, because the total duration is now 105. Okay, so by doing all this project crashing, all the allowable days to be crashed has been completely utilized, because all of the activity on the critical path B, C, D, E already crashed to the maximum allowable limits. Okay, then you need to recalculate everything and need to obtain the latest, the current or updated project duration or the total project duration. And then once you have the duration, for sure you need to recalculate for the new total cost. So by calculating all these what we call the additional cost for the project crashing, 600 for activity C, this one for C, 300 for activity A, 100, 300 for F, 100 for A. Okay, then you need to add up all these, and you got the new value that need to be deducted with the IC, indirect cost. So basically this is the final total cost or the new total cost. So based on this calculation for the project crashing, basically this is the summary. Okay, summary of what we have done previously. So based on this slope, we have the normal one, meaning that this one is the optimum or the actual proposed budget or proposed cost, which is 55,300 with within 140 days construction period or the total project cost. Then if the contractor try to crash the project to have a shortened construction period, maybe here we try to shorten for 10 days and it become 130 days. So the cost is slightly increased only for 100. If we further shorten the duration from 140 become 120, the cost is now start to increase. And as we can see here, as the duration shorten or decrease, time decrease, cost is increase up until here. Basically, 66,850 is the maximum cost that need to be bared by the contractor if they want to finish the project within 105 days. So basically they can have the view of how the project crashing or project shortening of the duration affect their cost. Okay, that's the main purpose of project crashing. Alright. So that's the steps for project crashing. So far you have any question? Any of you?
No, doctor.
No question? You have here. Alright. No Raini. Raini, do you have any question? The rest of you can understand, right? All of this step. Basically, it's quite tedious. However, the step is repeated actually. You need to repeat the same step until you reach the what we call the maximum allowable days to be crashed. However, for the purpose of what we call actual calculation for your, for example, assignments or for your test, you don't need to crash the whole project because in certain situation it is given that you need to crash certain or specific activities, not all the activities on the network. Maybe if you have 5 activities, you just need to crash 1 or 2 activities, just like that, not the all. Because the one I have shown here is that how actually project crashing can be done, meaning because this example is actually we crash the project up to the maximum allowable crash duration. So that's why the duration for each activity on the critical path all become 0. So this 0 meaning that you no longer can crash the project. So you already achieve the shortest duration to complete the project. Alright. I think that's all for the example for project crashing or project shortening. So now we will have come to the last part of our today's topic, which we will have the overview of sample questions. Because later on, I will give you another question regarding your individual assignment one, right? So one of the second question will be from this topic, which is project crashing. All right. For the overview of sample question one, basically this question is quite straightforward because it's just a simple calculation for you to calculate the direct cost loop. Okay, you just use all this given information in table 1 because you already have given every component, NC, crash cost, and also NT is actually ND, normal duration, and also CD. So based on this, you just apply into the cost loop formula as I presented earlier. Then you just simply obtain the values. Okay. So later on, you can try to calculate this or solve this question in order for you to obtain the correct answers. Alright, that's for sample question one. And then this is basically the most common question regarding the project crashing. I mean the most common form of question for you to solve regarding the project crashing. Okay, based on this table 2, it is given the information in table. Based on this table 2, you have given the information on activity. For sure, you need to have what kind of activity to be constructed, sub-activities. Then you have the information for time and also cost. And both time and cost divided into normal time and also crash. You have both information for the normal and crash condition. Alright, so you need to apply previous step in order for you to solve this kind of question. Okay, then we move to the what actually is the question. Okay, based on this table, there are several questions has been asked. Alright, the first one, regarding the indirect cost of the project, it is given or assumed that indirect cost per day is 250. Then you need to calculate the indirect cost of the project. So in order for you to answer this, because for the sample question 2 and maybe sample question 3, I don't provide any what we call the calculation details of the step. You need to try by your own. I just give you the correct answer and you may try by your own later on. Okay, so for sure, based on this information, based on the description or the question, you need to prepare firstly the network diagram. Network. So then for sure you need to know the direct cost. I mean the total direct cost. Then it is easier for you to obtain this value. And then once you have the direct cost, for sure you can calculate the indirect cost. And it is given that per day. So based on the network diagram, you will obtain the total duration of the project. Total duration. Okay, by using the information of total duration, you need to multiply or times with this given indirect cost, because the cost is daily rate on the daily basis. So then you will have the total IC cost for the question number 1. Alright. So The next one is that question number, not the question number one, question A. And then the next one is question B. Question B requires you to determine the activity, because previously we have these activities. Based on these activities, you need to, as I mentioned, you need to develop the network. Network diagram. Later on, you may try based on the previous calculation. Maybe here we have 1, 2, and 3. Okay, this basically activity 1 to 2 is refers to this relationship, 1, 3 to this, and then later on you need to complete this network in order for you to identify or to answer this question B, because you need to identify activity that indicate the lowest increment if time compression need to be done for the project. Any of you know what is the lowest increment, the meaning of lowest increment? Lowest increment is actually similar to what? If the time compression need to be done. So basically for the question 2B, what actually you need to calculate, you need to find? Can you understand?
Critical path ke doktor?
Tak, bukan critical path. Maksudnya lowest increment is actually refers to a cost or amount. So basically apa sebenarnya? What is,
Perbezaan ataupun kenaikan yang paling rendah.
okay, betul. So maksudnya so here is that we need to determine any activity because just now kan we have several types of activity. Which activity indicate the lowest increment? Basically, and actually it refers to the cost slope. This one, cost slope. So cost slope, because lowest increment meaning that the minimum, the lowest cost slope, lowest cost of the cost slope. So what is the main item for this question 2B is that they ask it asks you that which activity, if you compress, will affect the cost in the lowest increment. So meaning that you need to find the lowest cost slope, because lowest cost slope is the lowest cost slope will affect you the least during the calculation of total cost, right? Just now we already I already show you several calculation. So by considering the least cost slope, meaning that it will have the lowest increment of the total cost. So for the question to be, you need to calculate the cost slope, and then you need to identify the least cost slope at which activities are based on among these several activities. So the answer is here. So but you need to do your own calculation. Either you obtain the correct answer or not. Is it the same answer that you obtain here with here? Because it should be activity 4 to 6 to have the lowest cost slope or the lowest increment. Okay, that's all for question 2B. Then moving toward question C. So basically, question C required to do the crashing, the activity crashing or shortening the activity duration. So as I mentioned before, for the purpose of answering the question, it only asks you to crash only specific activity or some activity. So it will guide you to directly crash the related activity only, not all the activities. So for this case, you just need to crash activity 2 to 4 and also 4 to 6 based on this table. Only this and this one. Okay, out of I think 7 here, you only need to do project crashing or time shortening on these two activities only. So then similarly with the previous examples and calculation, once you have crashed the what we call the duration of the specific activity, you need to recalculate the new duration of the project, and also you need to find the new total cost as what has been shown previously. So you may try to prepare all the network diagram to calculate the cost slope and also crash the project. Then you have the new total cost, which is here. Okay, you can try later. Hopefully all of you can understand all the steps to what we call to crash the time or the duration. Then you may be able to answer this question. All right. Okay. So basically, this is the second sample question, and this is the sample question number 3. Okay. In overall, for this question is quite similar to the sample question 2 here, because the information is just quite the same. The main difference is that here you have the time in week. The first one you have in day. Okay, so any question can be into condition whether the duration or time in day or in week. So you need to notice this, because if it's given in weeks, later on if the any question require you to have daily basis, daily cost basis, then you need to convert week to the days calculation. Similarly, it is given the all the normal duration, crash duration, and also cost, which normal and also crash cost. Okay. For this sample question 3A, it's also about the indirect cost. Okay, for this question, it is given that indirect cost per day is 250. So it requires you to calculate the total cost by assuming 6 days working days a week except for Sunday. Okay, so here you need to convert the week the week duration to the days, because indirect cost is on the daily basis. So that's why you need to properly identify the given time or duration either in week or in days. Then it's once you have identified that, it is possible to you to obtain the correct answers. So you may try to calculate this, and I hope you able to obtain this answer. Alright. By the most important thing is that you need to understand and also identify and consider all the given details. Okay, that's for question A. Then for question B, vice versa of the previous one. The previous one, you need to identify the least, right? This one is the highest increment, meaning that you need to have the highest cost loop. What is the highest cost slope among these activities? Which one contribute to the highest one? So then this is the correct example, correct answer. Hopefully so far you can try to calculate all these sample question and obtain these given answers. Similarly, for the last question, 3C, it also require you to do project crashing for the specific activity 1 and 3. Okay, so you just need to repeat the same steps by starting with the previous step that I have shared with you. You have step 1 to step 6, starting from preparing the what we call preparing the network diagram here until you calculate the new total cost, which consider the indirect cost. If the given require you to assume the indirect cost. So that's why at the end you need to calculate the new total cost once you crash the project. So basically for this question, this is the correct answer. And I hope later on you can try by your own, and if you have any question regarding all this calculation, you may ask me anytime. Hopefully I will try to help all of you. Okay, with that I think that's all for our today's topic. And this is actually my final topic under my part for week until today week 11, week 12. So the next week will be covered by next instructor who is Dr. Farida Hanyu. Okay, that's all I think for our class, for our today's class, which is the third topic by me. So do you have any questions so far before we end our class? Any of you? Is it clear regarding all the steps?
I have no question.
Okay. Can I know who are you? Do you have question or not just now?
No question, Doctor.
No question.
No question. Okay. So far everything clear. So I think that's all from me. So before that, let me share the scan attendance code. Alright. You can scan the attendance now. Okay, with that, that's all from me. I hope all of you can understand the both conceptual and also calculation parts for the project crashing topics, and also for the previous topics on project cash flows. So that's all from me. Thank you, and have a good day.